This video will introduce VICS. VICS stands for Biomimetic Intrastromal Corneal Soft Segments. This innovative device is designed for the treatment of keratoconus and other forms of corneal ectasia. VICS combines the best features of two previously used techniques, ICRS and CARES, while addressing its limitations by utilizing a biomimetic approach. VICS closely resembles the properties of the human corneal stroma, offering a novel approach to intrastromal support. VICS is produced using HEMA, a soft biomaterial that mimics corneal stromal properties. Unlike rigid materials, HEMA offers a flexible structure that integrates more naturally within the corneal stroma. Biomimetics, derived from the Greek words bios, life, and mimesis, to imitate, is a design concept that takes inspiration from natural biological structures. VICS applies these principles by utilizing a material that replicates the biomechanical and optical characteristics of the corneal stroma. The key properties of VICS include a soft texture, allowing it to resemble the native corneal tissue, a high water content of 78%, promoting integration within the corneal stroma, an identical refractive index to the cornea, which may minimize visual disturbances such as halos and glare. These properties suggest that VICS has the potential to enhance intrastromal integration while preserving corneal's natural optical characteristics. The early clinical experience with VICS has provided valuable insights into its behavior in vivo. Being among the first to work with this device, I have had the opportunity to contribute to its initial clinical evaluation, allowing us to assess its biomechanical and optical performance. Continued follow-up will be essential in further understanding its long-term effects and refining its applications. Here is the surgical footage of the implantation technique, followed by the outcomes observed in the initial cases.
After carefully extracting the VICS from the bottle, they are placed into a Teflon block. At this stage, we can customize them by cutting them to the desired arc length. Once positioned in the Teflon block, the VICS are left to dry for 10 minutes to facilitate easier implantation. The stromal tunnels are created using a femtosecond laser. In this case, the LDV from Zimmer was used. And after 10 minutes drying period, the VICS were removed from the Teflon block and grasped using the Kera rings forceps for implantation into the tunnel. We begin by opening the main incision using a Sinskey hook, and the segment is then gently slid into the tunnel. As observed, the segment becomes slightly rigid after drying, but softens quickly, making the insertion smoother. The initial part of the procedure should be performed promptly to take advantage of this temporary rigidity. Using the holes along the segment, we continue to advance it into the tunnel with the help of the Sinskey hook through the main incision as seen in the video. The segment is progressively pushed until most of its position within the tunnel. And finally, through the distal incision, we insert the reverse Sinskey hook to perform the final adjustments and precisely position the segment in its intended location. These are three of the initial cases in which VICS were implanted. The topographies on the left show the preoperative scans. In the middle, we see the 1 month postoperative scans, and on the right are the differential maps, illustrating the flattening effect achieved in each case. As shown in the middle column, the implantation of the VICS led to significant corneal regularization in all three cases.
The results observed so far, along with the design concept, suggest that VICS could offer a promising approach for the treatment of keratoconus. This device addressed key limitations of the currently available options, ICRS and CARES, while preserving most of their advantages.